Welcome back. So in our previous lectures, we have covered two important topics, that is the electrovalent compounds and the covalent compounds. Now, in this video, I will be discussing about the third kind of chemical bond, which is a coordinate bond. So before beginning with this, please do hit the like button, share the video with your friends, and subscribe my channel. So let's begin. Now, what is a coordinate covalent bond? It is a type of a chemical bond which involves one of the combining atom contributing both of its shared electron. That is, a bond is formed by a shared pair of electrons with both electrons coming from same atom. Suppose I'm taking an example A and B. Okay, assume A has an extra pair of electrons and B does not have any electrons. So what will happen in case of coordinate bond? These both the electrons which are needed to form a bond will be contributed from A itself. Okay, and it will be shared with B. Okay, so we will form a bond like this where the electrons are coming from only from one single atom. Okay, so this kind of bond formation is called coordinate bond, and there's another term for it. Instead of coordinate, you can call as a dative bond as well. In your syllabus, there are two important examples where you need to show the coordinate bond formation. The first one is the hydronium ion, that is a H3O plus ion, and the ammonium ion, that is a NH4 plus. Okay, so let us discuss the examples in details. Before going on to discuss the examples, you need to know what are the conditions required to form a coordinate bond. The first most important condition is that one of the atom must have one lone pair of electrons. I will explain what is a lone pair. And second, one is the other combining atom should be at least short of one lone pair of electrons. That means it should not have electrons, and one should have excess electron. So what is a lone pair? Suppose in the previous lecture you have seen in water over oxygen, two pairs of electrons did not participate in bond formation. The pairs of electrons which did not participate in bond formation are called the lone pair. They are left behind, lone. Okay, these are called lone pairs. Okay, so in water there are two lone pairs. Similarly, in ammonia, you will see there is a one lone pair over nitrogen, which did not take part in bond formation. This unshared pair of electrons which did not take part in bond formation are termed as lone pair. Okay, okay. Suppose if someone is giving something to you, you will call them as donor. Okay, and if someone is accepting something, is they are called acceptor. Similarly, if an atom provides a pair of electrons, they are called donor atom. And if an atom accepts a pair of electrons, they are called acceptor atom. Okay, this was the concept. Now let us understand few examples of coordinate bond. The first one is the formation of hydronium ion. Now the formation of hydrogen, so formation of water was discussed in previous video itself, where you have seen oxygen was placed at the center and two single covalent bond was formed, and we have two lone pairs over the oxygen atom after completing its octet. Now the hydrogen ion, that is hydrogen ions are formed when it has already lost its electron. That means it does not have any electrons in its outermost shell. So what will happen? The hydrogen ion, as it is deficient of electron, it will accept a lone pair of electrons from the oxygen atom of water molecule, leading to the formation of coordinate bond. And coordinate bonds are denoted by a arrow. What will happen? These lone pairs will be donated to the hydrogen ion, and we will form a coordinate bond between oxygen and hydrogen. Okay. Similarly, we have one more example, that is of ammonium ion. Ammonium ions are formed when ammonia is react with an hydrogen ion. Similarly, as discussed in water, in ammonia, the nitrogen contains one lone pair of electrons. See, this is a lone pair. And this lone pair of electron is accepted by the hydrogen ion. This. Okay. Which would lead to the formation of coordinate bond. Okay. So here nitrogen is a donor atom and hydrogen is an acceptor atom. Okay. In an exam, you are either asked to draw the hydronium ion, the HCO plus, or the ammonium ion. Or you may be asked a question, you define a lone pair. What are lone pairs? Give an example of a molecule having two lone pairs or one lone pair. Okay, this sort of question comes in exam. Now, we will learn certain differences between electrovalent compound and covalent compound. Okay, and the differences are based on the properties of electrovalent compound and covalent compound. The first property is the state. In which form does electrovalent compound exist? Electrovalent compound exists as a hard crystalline solid, and the force of attraction between them is very strong. Why does it have a strong force of attraction? It is because the, as electrovalent compounds are formed due to the charged particles and they are closely packed. As they are closely packed, there is a strong force of attraction between them. Hence, the ionic compounds are hard solid. Okay. The second property of ionic compound or covalent compound is the volatility. They are non-volatile. As it is hard crystalline solid, it does not easily evaporate. They have a high melting and boiling point. The high melting and boiling point is due to the strong electrostatic force of attraction between the ions. As the force of attraction is very strong, large amount of energy are required to break the force of attraction. Okay. Similarly, they are good conductors of heat because for conduction of heat you need ions, and as their electron valent compounds are itself formed from ions, so the flow of ions are more, so they are good conductor of heat. Now in case of covalent compound, the state, they exist as gas, liquid or soft solid because due to the weak van der Waals force of attraction present between the molecules. Okay, molecules have weak force of attraction between them, hence covalent compounds are generally gaseous and liquid. Volatility, they are highly volatile. It's just because of the weak van der Waals force of present between them, hence lesser energy will be required to change the state of matter. They have a low melting and boiling point because of the weak van der Waals force present between them. Less amount of energy will be required to break this force, and they will easily break down. They are bad conductor or non-conductor of heat because of lack of ions. They have large amount of molecules present in them. The next property is the conduction of electricity. They are bad conductor of electricity because the strong electrostatic force keeps the ion in a fixed position. But the force is weakened in this molten state or in liquid state because in molten liquid state the ions are free and they easily migrate toward the respective electrode. Electrolysis, they can easily be electrolyzed in molten and aqueous states, similar explanation as stated above. Reaction, they undergo high speed reaction because they are composed of ions, and free ions are easily formed in solution which rapidly regroup in solution. Therefore, they have high ionic speed reaction. Solubility, they are more soluble in water than in inorganic solvent. Water is a polar solvent, that is, it has a charge separation, and thus it has a high dielectric constant. It is a capacity to weaken the force of attraction, thus resulting in free ions, which makes them more soluble in water. Whereas an ion in organic solvent, which are non-polar, that does not have any charge separation between them, have low dielectric constant and do not cause dissolution. Okay. In case of covalent compound, they are bad conductors of electricity because of weak force of attraction. They cannot be electrolyzed in normal state, but if some polar covalent compounds are used in aqueous state, they can easily be hydrolyzed because they break down into respective ions. They undergo slow molecular reaction because covalent bonds are first broken and then new bonds are slowly established. Therefore, they have a slow speed. Solubility is just the reverse of electrovalent compound. They are more soluble in organic solvent than in water because, as you have studied in your junior classes, that like dissolves like. So since they themselves are non-polar in nature, they will prefer to get solubilized in a non-polar solvent. Last point is the dissociation. Electrovalent compound undergo electrolytic dissociation on passage of electricity. The process involves separation of ion already present in ionic compounds. As you know, in electrovalent compound, they already have ions. So just passage of electricity, the ions will get separated. Okay, you do not, you just need to ionize the compound. But in case of covalent compound, they undergo ionization, not dissociation, because they are composed of molecules, so they need to be ionized. Okay, they need to be ionized. So they undergo ionization rather than dissociation. Okay, so this was all about your chemical bonding chapter. So till now I have covered all theory portion. In my next video, I will be discussing with you all the previous year question with you all. So if you have any doubts, please do write in the comment section box. I will be solving your doubts as well.